Hi guys, this is Mr. Mellor. This is a quick lecture video on free fall. This is the second asynchronous lecture we've had on this topic. What you're going to do is just make sure to, in your notebook, record the main points from this lecture. We will turn those in at the end of the unit like always. So, what about free fall? Very quickly, let's recap what we've talked about so far. We have this concept of acceleration due to gravity. Remember, acceleration is the rate at which an object changes its velocity. So it's the how quickly an object will pick up speed, decrease speed, or change direction. And so gravity will cause objects to accelerate at 9.8 meters per second squared. That means every second, if an object is in free fall, which again means when only gravity is acting on an object, it will change its speed by 10 meters per second every second. Okay, and so the example we talked about in class was we dropped an object. The instant that I let go of that object, or you let go of that object, it's at a speed of 0 meters per second. It hasn't had time to pick up speed. 1 second later, the acceleration due to gravity is going to cause that object to be at 10 meters per second, because our acceleration due to gravity is approximately 10 meters per second every second. 1 second later, we're at t equals 2 seconds. We're at a velocity of 20 meters per second. A second after that, we're at a velocity of 30 meters per second. 1 more second after that, we're at a velocity of 40 meters per second. So hopefully you guys can see the pattern here. The acceleration due to gravity. So remember, acceleration, again, is that change in velocity over time. How do we get acceleration? Well, that comes from a push or a pull, a force. And so you guys are familiar with that in your everyday lives. If you, say, push on an object, you can get its motion to change. It's sitting still to then push on it, and it will start moving. It will start accelerating. It's gone from a speed of 0 to a speed of not 0. All right, and so in this case, our acceleration due to gravity is 10 meters per second every second. If we're in free fall, the absence of air resistance. All right, so our final one is going to be a speed of 50 meters per second. We're increasing by 10 meters per second every second as a result of the acceleration due to gravity. All right, very good. Let's do a quick check question. So on Edpuzzle, go ahead and answer A, B, C, or D, what you think the answer to this question is. An apple drops from a tree and strikes the ground in 1 second. What's its speed the instant before it strikes the ground? So right before it's struck the ground, that would be, what is its speed after 1 second? All right, so go ahead and answer that, knowing that it starts at rest, starts at a speed of 0. All right, so moving on. The answer is actually B. So remember, our acceleration due to gravity causes speed to change at 10 meters per second per second. Since 1 second has elapsed, the object got up to a speed of 10 meters per second. All right, if we were to, say, fall for 1 more second, then we'd be at 20 meters per second, and another second after that, we'd be at 30 meters per second. So we know our object is picking up speed as we go. We talked about in class, if you dropped a penny from the top of the Empire State Building, it would get faster and faster. All right, next one. What about if we were to throw an object upwards? Remember, we talked about you're with your friends and you shoot an arrow into the sky and you all start running because you know that if your arrow is going up, it's going to come down. You don't want to be in the path of that arrow. So gravity is always acting downwards. And in the case where our object is moving upwards, if the direction of the object is up but gravity is down, gravity is going to cause that object to slow down. Okay, so we, in this case, start at a speed of 20 meters per second. We know that acceleration due to gravity is approximately 10 meters per second as long as we're near Earth. So this is the value that we're trying to start using. All right, so 1 second after we've launched our arrow into the sky, it's now going 10 meters per second less than it was. Why less? Whereas in the previous problem, we were adding to our speed. Well, again, that's because our arrow is going up and gravity is acting down. And gravity wants our objects to fall towards the Earth. Okay, so 1 second after that, we end up with a speed of 0 meters per second. That's the peak of our arc. 1 second after that, we're at negative 10 meters per second. After that, we're at negative 20 meters per second. After that, negative 30 meters per second. And after that, negative 40 meters per second. But what does this negative mean? Can we have a negative speed? Is it possible to go negative change distance negatively. What? That doesn't make any sense. Okay, but what it actually means is direction. So in this case, this problem, we defined up as our positive direction. That's why we had positive 20 meters per second, and then we had positive 10 meters per second. But once we started going towards the Earth, our direction has changed. And so remember, velocity is speed with direction. So in this case, we had our velocity negative 10. That means it's going 10 meters per second towards the Earth. Then at t equals 4, it's negative 20 meters per second. It's going 20 meters per second towards the Earth. That negative is just telling us the direction is downwards. All right, let's look at v equals 0 meters per second. So that's when your arrow starts, it has gotten to its top point. It's the transition from going up to going down. All right, so if an object's going up and then a little bit later it's going down, we know that in between that up and that down, there must have been a point where it transitioned, right? And so that transition is when we go from a speed in one direction to speed in the other direction. And so at that transition, we must have a speed in the vertical direction that's 0. So at the very tip, the very pinnacle, there's a instant where our speed is 0 in the vertical direction. Okay, so let's move on. All right, same example. An arrow is launched upwards at a speed of 30 meters per second. What is its speed at t equals 3 seconds? Remember that acceleration due to gravity causes a change in velocity at 10 meters per second per second. So gravity is acting down, this speed is up. So what would its speed be after t equals 3 seconds? All right, go ahead and answer that now. All right, so the speed is 0 meters per second. So what is happening? Well, the acceleration due to gravity causes our speed to change by 10 meters per second. Since 3 seconds have elapsed, the speed must be moving at 30 meters per second minus 3 times 10 meters per second, which is 0 meters per second. This is the peak of the arrow movement. And then you just, obviously, you want to get out of the way because it's going to start moving downwards towards you. All right, let's look at an image of what that looks like. So our arrow is going up with a upwards velocity speed with direction, and then we have gravity is acting downwards. And so as we go from a upwards velocity to a downwards velocity, there must be a speed at which it's 0. Since we're going upwards in this case, after 3 seconds, we have reached our peak, and we're going to have our arrow start going down. All right, the next part. So this is the new material for today. Ooh, we're 7 minutes in. All right, how far is an object going to fall? So distance that an object falls increases with time. We know this because velocity, remember, is distance covered over time. So if our velocity is getting faster and faster as our object is falling, the distance must also increase with time, but increase at a much faster rate than, say, a linear increase because our speed is picking up. All right, so here's our situation. At the end of 1 second, a rock has fallen 5 meters. At the end of 2 seconds, so say we've taken this data, it has fallen a total distance of 20 meters. And at the end of 3 seconds, it's dropped 45 meters altogether. And so between 1 second and 2 seconds, you can see that there's a difference of 15 meters. And between 2 and 3 seconds, you can see there's a difference of 25 meters. So the distance an object is falling is changing exponentially. All right, so here's a scenario. You're a student of physics. There is, say, a very attractive person who's at the edge of a cliff. You guys are on a vacation with a busload of people. And so this very attractive person is standing on the edge of the cliff and wondering how tall that cliff is. And so you, being a student of physics, are thinking, I know how to calculate the speed at which an object is falling, but I don't know exactly how to calculate the distance the object has fallen. And so at this point in time, another person comes up and says, well, I think it is d equals 1/2 gt squared. And he goes ahead and impresses that person, and you're a little bit bummed. But then the next day you come back to that same place with a different group of people, and there's another, say, attractive person that you're interested in, and she's wondering, or he's wondering, how far down the cliff goes. And so you go ahead and you take a rock and you drop it after you've studied a little bit more, and you listen. 1, 2, 3, 4, 5 seconds, and it hits the ground. All right, and so the distance an object falls over a time interval t is related by this equation. Distance is equal to 1/2 times the acceleration due to gravity times t squared. Where does that come from? Well, that comes from our equation. Remember, acceleration is equal to the change in velocity over time, and the other equation, velocity distance is equal to velocity times time. And so if we plug in those, we manipulate those two equations together, we can eventually get this equation: distance is equal to 1/2 gt squared. All right, so you dropped your object, you listened to it, it hit the ground at 5 seconds after you dropped it. So you could go ahead and plug into this equation. You'd have 1/2 times 10 meters per second squared, so that ends up being 5. 5 times our time squared, so that would be 5 times 25. And so you'd end up with 125 meters. And you can go ahead and tell your crush, well, it took 5 seconds to land. That must be 125 meters. I'd recommend not jumping off. And she's very impressed. You're very happy, and you live happily ever after. Or maybe he's very happy and you live happily ever after. It is wonderful. So many joys of studying physics. Okay, so the distance an object falls with time is equal to 1/2 times the acceleration of gravity times t squared. So after 1 second of dropping an object, our distance fallen is 5 meters. That would be plugging in a time of 1. So 1 squared is 1 times 10 is 10. 10 divided by 2 is equal to 5. Then after another second, you're at 20 meters. We plug in t equals 2. 2 squared is 4. 4 times 10 is 40. 40 divided by 2 is 20. Okay, so you can see that after each second, our distance that the object has fallen overall, this is our total distance, is described by this equation. Okay, and so if you were to say, remember this equation in the future, and you were ever wondering how deep a hole was, you could drop an object, listen to when it hits the ground, and then you could apply this equation, remembering that g is approximately 10 meters per second, and you could impress all your friends and find out how deep things are. All right, so here's a quick check question. An apple drops from a tree and hits the ground in 1 second. How high above the ground was the apple when it first dropped? All right, so go ahead and apply your equation. T equals 1 second. G is equal to 10 meters per second squared. Go ahead and apply that equation and solve for the total distance it dropped. All right, so the answer in this case is 5 meters. We plugged into our equation. We said distance is equal to 1/2 times the acceleration due to gravity times the time squared. So we get 1/2 times 10 meters per second squared times 1 second. That ends up being 5 meters. So the apple fell 5 meters in 1 second. All right, next check question. A ball is dropped from the top of a cliff and lands 10 seconds later. How far did the ball drop in 10 seconds? All right, go ahead and plug into this equation again and find out how far the ball dropped. All right, the answer was 500 meters. How did we get that? We plugged in 1/2 times 10 meters per second squared times 10 seconds squared. That's 100 times 10 is 1,000. 1,000 divided by 2 is 500. So the ball fell 500 meters in 1 second. All right, so to summarize what we just talked about, we talked about how an object picks up speed at 10 meters per second. If you dropped an object 1 second later as a result of the force of gravity, that object would be at 10 meters per second. A second after that, you would be at 20 meters per second, and a second after that, you'd be at 30 meters per second. If we wanted to find out the distance an object falls over a time interval, we could drop the object, listen to when it hits the ground, and we say, okay, it took 2 seconds to hit the ground. Then you would plug into this equation. Distance is equal to 1/2 times the acceleration due to gravity times that time squared. All right, and then you could calculate how far the object had fallen in a certain amount of time. Okay, so these two images on the side, just be aware that these numbers, 4.9, 19.6, those are unrounded numbers. Remember that acceleration due to gravity is actually 9.8 meters per second squared. We round it up when we do our calculations to 10 meters per second squared. And so these numbers represent that rounding. All right, see you in class.